All right, in my last personal recording, I'm going to explain how to draw Lewis structures and some of the rules for drawing Lewis structures and work a couple problems for you. That doesn't mean you shouldn't watch the other videos to learn about the ozone layer and how sunscreens work and how, facial lotions, do they really, diminish lines and make us look younger, because there's some really cool chemistry in those videos too. But let's talk about drawing Lewis structures. So if we think about the overall shape of the periodic table, this is kind of what it looks like. Remember, we have different groups. This is group 1, this is group 2, this is group 3A, 4A, 5A, 6A, 7A, 8A, and then this is group 3B, 4B, 5. These are the B's down here. And then you've got your lanthanide actinide series. The good news about the Lewis structures we're going to be drawing is that I'm going to get my nice bold pen here, is that we won't look at anything in this area in the B section. These are sometimes referred to as D block elements. And we're actually not going to do anything with the lanthanide or actinide series. So you're only going to be responsible for drawing Lewis structures in compounds that have, let's just actually erase all this stuff. Compounds for elements that are found in these groups. So group 1, I'm going to draw numbers. Group 1, group 2, we're calling this group 3, group 4, group 5, group 6, group 7, and group 8. And if you remember from my original periodic video, group 8, these are our noble gases. Group 7, these are our halogens. Group 1 is the alkali earth metals, and group 2 is the alkaline metals. So 3, 4, 5, and 6, those don't really have an overall name about them. But when you have to draw a Lewis structure, if you find out on the periodic table in which group that element is, then it has the same number of what's called a valence electron. So quickly, let me tell you the difference between valence electrons and core electrons. So every element has a nucleus at its center and electron cloud that surrounds that nucleus. The core electrons, actually it's easier to explain what valence is. The valence electrons are the number of electrons on the outermost shell. So each time you go down a period, so periods come down this way, each time you go down a period in the periodic table, you can think of adding like another layer of electrons, out from the nucleus. So if you're hydrogen or helium, you only have 2 electrons that are in like shell 1. If you move down to lithium, that's right here, the very third element, you have those, it has a total of 3 electrons. So it has 2 in the first shell, and then it has a second shell that has only 1 electron in it, okay? So the valence electrons are the number of electrons that are found only in the outermost shell. And the core electrons are all the other electrons that are essentially between the nucleus and the valence electrons. Okay? Core electrons we don't care about when drawing Lewis structures, because the only types of electrons that can actually form bonds are the valence, because they are on the outside part. Right? Think of 2 spheres coming together. The only way that they'll touch and be able to share electrons is on the outside. They're not going to be sharing their nucleus together. In fact, if you smash nuclei together, you have nuclear fusion, which results in massive amounts of energy being released like in the sun, right? So we don't want that. So we only worry about valence electrons. And now the good news about drawing Lewis structures is that it is essentially, it could be pretty repetitive. Well, again, in group wise. So if anything, any element that you're starting with comes from group 1, I'm just going to put an X, and that means any element. It only has 1 valence electron in its outer shell. So you only have to worry about draw it with 1 dot. If it's anything in group 2, guess what? It has 2 dots. So 2 electrons in its valence. If it's in group 3, guess what? How many it has? Yep, you'd be right, 3 valence electrons. If it's in group 4, it would have 4 valence electrons. If it's in group 5, it would have 5 valence electrons. If it's in group 6, it would have 6 valence electrons. If it's in group 7, it would have 7 valence electrons. And if it's in group 8, it has a full octet of valence electrons, and that's why it doesn't want to share any with anybody. Like, it's totally fine, it's happy, it doesn't need anybody, and that's why noble gases don't react with anything. So if you remember this kind of rule that anything in group 1 has 1 valence electron, group 2 has 2, group 3, 4, 5, 6, 7, so on and so forth, that's the best start to drawing Lewis structures. Okay. Remember also in my last video, if you can misspell the word honk, H-O-N-C, and count to 4, 1, 2, 3, 4, you can figure out how many bonds that those 4 common elements will always have, right? So hydrogen will always make 1, oxygen will always make 2 bonds, nitrogen will always make 3 bonds, and carbon will always make 4 bonds. Okay. All right, so let's work some examples. All right, that's the best way to do it, is just like maybe I'm gonna work like 4 examples, okay? If we start, I'll start with your turn on page 319 on page 91 in your textbook. It says, draw the Lewis structures for the following molecules. And the very first one is HBr, okay? So what groups, so if you were working this problem, I would suggest now find the element and then figure out what groups those elements are in. So hydrogen is the very first element and it's in group 1. So I'm gonna write a 1 right here. And bromine is, I need a periodic table. Oh wait, it's probably one in my book. I don't remember the bromine number. Is it number 35? Oh, here we go. I got it at the very end of my book. Back of the book, last page. Bromine is element number 35. Wow. That means it has 35 protons and 35 electrons. But it's in group 7. Okay, so it's in group 7. So if we were to draw hydrogen by itself in its Lewis structure, remember we would draw hydrogen with 1 dot, and if we draw bromine, it would have 7. 1, 2, 3, 4, 5, 6, and 7. Okay. Typically, when you're drawing these Lewis dot structures, possibly a better thing to do is to draw, if it has more than 4, draw 4, like 1 each on each side, and then go back in and start filling in 2s. Because what you see a lot of an atom is those lone pairs that are grouped together, okay? So if we wanted to create a chemical bond between hydrogen and bromine, that means that we need to share 2 electrons between hydrogen and bromine. And hydrogen has this lonely electron right here, and bromine has this lonely electron right here. So I would draw it so that hydrogen has the bond to bromine, HBr, and remember this line is representing these 2 electrons that are now being shared between the 2 atoms, and bromine has how many electrons remaining? 1, 2, 3, 4, 5, 6. It has 6 electrons remaining. 1, 2, 3, 4, 5, 6. Oops, sorry. So it has 6 electrons remaining. So you would put those dots around the bromine. You could also say that it has 3 lone pairs, right? So 3 lone pairs, because 1 lone pair is 2 unbound electrons. So electrons that are not in bonds, okay? Typically, anything in group 7 down the periodic table, that's going to be your fluorine, your chlorine, your iodine, your bromine. Those are all going to make 1 bond and have 3 lone pairs around them. It's very, very, very common. All right, so let's look at their next example, which the next example is Br2. Okay. We just, from the last example, know that bromine is in group 7. And we need to link up 2 bromine atoms together and create, like, what does that molecule look like? So bromine, remember, let's draw the valence electrons. It has 7 valence electrons. Remember, 7 electrons on its outermost shell. 1, 2, 3, 4, 5, 6, 7. And then we're gonna do that a second time, because I've got to link up 2 bromines. 1, 2, 3, 4, 5, 6, 7. All right, so there's my 2 bromines that have 7 valence electrons around the atom nucleus. And like I just said, things that are in group 7 tend to only make one single bond, have one single bond and 3 lone pair around them. So I want to link up this electron with this single electron. I'm not going to touch these ones because look, they're already in their lone pair status and they're already, you know, they're fine. They're having a great time together. Lone pairs can exist and it's great. But these like single electrons, they probably want to have a friend. So if I were to draw the correct structure of Br2, I would draw the 2 bromine atoms with a single bond in between them, right? And that single bond is these 2 electrons. And then I would draw 1, 2, each bromine should have 3 lone pairs. And that would be how you draw Br2. Let's do something a little more uppity. I think on the next page, yeah, look at this. So your turn 3.20 on page 92. Now they're asking us to draw hydrogen sulfide, H2S. All right, and here's where we need to go look on the periodic table. We know that hydrogen is in group 1, and we also know from spelling the word honk that hydrogen always likes to make just one bond and only one bond. You're never ever going to see hydrogen with a double bond or a triple bond. Never, ever, ever. Like never. Doesn't exist. Only ever a single bond. So now we just need to find out what group sulfur is in. So we know that hydrogen is in group 1, but where is sulfur on the periodic table? And ooh, I think it's element 16. Bing, bing, bing. It's element 16. And if you count across, it's in group 6A. So that makes it in group 6. Okay. All right. So if we know how to draw our hydrogens, right? Our hydrogen dot structures, because hydrogen only has 1 valence electron. And now how do we draw our sulfur? Okay. Sulfur is group 6. So let's go around and add the valence electron. So 1, 2, 3, 4, 5, 6. All right. Off the bat, it looks like my sulfur has 2 lone pair, and I've got 2 single electrons that might want something to bond with. I also need to pair it up with 2 hydrogens electrons that need to make a single bond only. So this electron will pair up with that, and this electron is going to pair up with that, and that's going to give me my correct structure of H2S, which there's a bunch of different ways you could draw it, but I'll draw it in kind of this linear fashion where I've got my hydrogen with a single bond to the sulfur atom. The sulfur has 2 lone pairs on it. Check that out from our valence structure over here, or our Lewis structure over here. And then the sulfur has its second single bond to this hydrogen. So that would be how you draw the Lewis structure for hydrogen sulfide. Okay. Last one is let's draw the Lewis structure for dichlorodifluoromethane, which is Cl2. Sorry, I was like, wait, didn't I say di? Cl2F2. Okay. All right, so let's find out where all of these things are on the periodic table. Carbon is element number 8. It's actually embarrassing that I don't know that one and I got bromine and sulfur right. Did I get it right? Carbon is 6. I knew it. Carbon was 6. All right, sorry. So carbon is element number 6 and it's found in group 4. All right, so this is group 4. Chlorine and fluorine are halogens. Both of those are in group 7. And what are some of these kind of common rules that I've already told you about some of these elements? Remember, carbon will always make 4 bonds. Now that doesn't mean it has to be 4 single bonds. It could be 1 triple bond and 1 single bond, because that would be a total of 4, right? 3 plus 1. It could be 2 double bonds, because 2 plus 2 is 4, right? But carbon will always make 4 bonds. And the halogens will make 1 bond and have 3 lone pair. Okay, you won't see a halogen with 2 bonds. So halogens, in a sense, are almost like hydrogen because they only make 1 bond. The big difference, obviously, is that halogens have 3 lone pair and hydrogens have no lone pairs. Okay, so I have a carbon atom, 1, 2, 3, 4. I have a chlorine, sorry, 1, 2, 3, 4, 5, 6, 7. I know that all these halogens have 7. So each side leaves me with 1, 3, 4, 5, 6. Each side leaves me with 1 unpaired electron. And fluorine, 1, 2, 3, 4, 5, 6, boom. And so you can kind of see I drew that strategically so I could start to link up those unpaired electrons. So I could connect those 2 electrons and make a single bond. I could connect these 2 single electrons and make a single bond. I can connect these 2 electrons and make a single bond. And I can connect these 2 electrons and make a single bond. And then you would have the proper Lewis dot structure of methane. And so what that would look like, let me just erase all that. All right, get my pen back. So what would the final answer be? You'd have a carbon center. You would have 4 bonds coming off of it. They were all single bonds. You had fluorine with 3 lone pair, second fluorine with 3 lone pair, a chlorine with 3 lone pair, and a second chlorine with 3 lone pair. Okay, so it actually doesn't matter if I put this fluorine over here, like that doesn't matter because the fluorine's still bound on the carbon. So the order of the fluorines and chlorines around this carbon center makes no difference, but this is in a nutshell kind of working in drawing some of these Lewis dot structures. I highly suggest that you can practice some more of these your turns. You can also do problems at the end of the book, and I will post a short video on how to use Chem 101's Lewis dot structure app right after this video. So watch how I do that because the Chem 101 platform has something really cool that it does.